chat or any message anywhere?
I was having trouble with solving quadratics with the quadratic formula.
Okay, so if you have a quadratic equation, you can use this formula to get the answers for x. It's the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And here's an example. Let me get one here. So if I have this quadratic equation, x squared plus 3x minus 4 equals 0. It has to be equal to 0 for this equation to work. And when you look at this, the number in front of x squared is a. So a is 1. The number in front of b, or b is the number in front of the x. So on this one, b is 3. And the number that's hanging out there by itself, this one, is c, sign included. So I can use this formula now because I know what a, b, and c are to get the answers for x. It's the opposite of b. Since b is 3, it's going to be negative 3, plus or minus the square root of b squared, 3 squared, minus 4 times a times c, all divided by 2 times a. Okay, look that over for a minute before I go on. Do you see where all the numbers are coming from? You have to look at the question and figure out what A, B, and C are. And then you fill them into the formula. The opposite of B, so since B is 3, negative 3, plus or minus the square root of B squared minus 4 times A times C. It's just a coincidence that they're both negative 4. All divided by 2 times A. So let's see, negative 3 plus or minus the square root of 9 plus 16, all divided by 2. And you can use a calculator to do that. 3 squared is 9, and 4 times negative 4 is negative 16, but there's a minus there, so it's plus 16. So x equals negative 3 plus or minus the square root of 25 over 2. And the square root of 25, again, you can use a calculator if you want. That one turns out a nice perfect number. That's 5. Negative 3 plus or minus 5 over 2. And then here's where you're going to get two answers. This is really two equations. It's negative 3 plus 5 over 2, or the other answer, x could be negative 3 minus 5 over 2. Negative 3 plus 5 is 2 over 2. That's 1. Let's see over here. Negative 3 minus 5, that's negative 8 over 2. That's negative 4. There's the two answers. X is either 1 or negative 4. It's a lot of work. It takes a little bit of practice, but the formula will get you the answers every time.
Where did you get the 3 and the 1?
This one right here.
Oh, wait.
Oh, up here.
Oh, wait. Yeah, sorry, I got the top one in the equation confused.
Okay, so back right up here. Yeah, this is, do you see where the A, B, and C come from? This is A, the number in front of x squared. This is B, the number in front of x. And this is C, the number that's hanging out there all by itself. So once you've got that down, and I always write it down on the side of my paper like this. Once you've got that figured out, then you just put them into the formula. The formula says the opposite of b, so it's a negative sign, and then the 3, negative 3, plus or minus the square root of b squared minus 4 times a, that's 1, times c, that's negative 4, all divided by 2a. And then it's a matter of working through it slowly and carefully. You want to look at another one? Here's another one. Let me get one. I have to write one down first.
Can I take a picture of that one real quick?
Oh, sure. I'll put that back here. There you go.
Thank you.
You're welcome. Okay, let me see. Okay, here's another one. What if I have this equation? 2x squared, sorry, 2x squared plus 1x minus 3 equals 0. Okay, there's the equation. Can you tell me by looking at it what a, b, and c are?
A would be
the number. Yeah? The number in front of x squared.
Squared. 2.
Good. B,
and then
this is
B
the tricky.
B
The number
X.
in front of x. What's the number in front?
1.
Very good. A lot of people forget that. That's a 1. And what's c?
3. Negative 3.
Very good. You got the sign too. Okay, now that I know a, b, and c, I can follow the formula. Here it is again. X equals the opposite of b plus or minus square root of b squared minus 4ac, all divided by 2a. It's a monster. Okay, so x equals the opposite of b. Here's b, it's negative, or it's 1. So the opposite of that is negative 1. Plus or minus the square root of b squared, that's 1 squared, minus 4 times a times c times 2 times negative 3, all divided by 2 times a. Okay, before I go on, look at that. Check that all out. You see where all those numbers are coming from?
Why is the 1 negative? Oh, opposite.
It's
right?
The opposite of b. Yes. Yep. Since b is positive 1, it's going to start off with negative 1. And this 4 is just part of the formula. And that's a and that's c. Okay, so now let's see. When you start with what's inside the square root here. 1 times 1 is 1. 4 times 2 times 3. 4 times 2 is 8, times 3 is 24, and the 2 negatives make it plus 24. And you can use a calculator if you want to. All divided by 4. Check that out again before I go on. You see why the 4 is on the bottom?
Because 2 times 2 is 4?
Yes. And do you see where this 24 comes from? That's kind of tricky. 4 times 2 times negative 3 makes negative 24, but there's already a minus sign there. So it's really like 1 minus negative 24, which makes it plus 24. So it's 1 plus or minus the square root of 25 over 4. Just a coincidence that I made up one with 25 again. Don't know how that worked out. That's negative 1 plus or minus 5 over 4. And now is when you got to split it up into 2 problems, because this is really 2 different equations. It's -1 plus 5 over 4, or it's this, -1 minus 5 over 4. It's 1, or -6 over 4. That's -3/2, or -1 1/2. You can use a calculator and go -1.5. There's one of the answers, and there's one of the answers. Okay,
So
let's look at one. Stop, you want a picture of this one too?
yeah. So
Okay.
Okay. I think I'm understanding this.
Good. I want to get to a tougher one that doesn't have such a nice number under the square root. So go ahead and take a picture of this one.
Okay.
Okay. What about if I have this one? Let's see. 4x squared minus 3x minus 8 equals 0. I think that'll work. I'm trying to make sure it will work out good. Yeah, always have to be sure you have this 0 here before you find A, B, and C. So can you tell me what A, B, and C are?
A would be 4.
Very good.
B would be -3.
Very good.
And C would be -8.
And very good. Okay, so that's getting easy, isn't it?
Yeah.
Just got to watch out with signs. Okay, so now the formula says x equals the opposite of b. Since b is -3, the opposite
it'd be a
of b
positive.
is 3. Yep. Plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, check that out and look at all of that. You're smart to see that +3 there. Does everything else make sense?
Why? Okay, so the A under 4. What do you do when you have that -3?
Squared,
Mm-hmm.
this part?
Yeah.
So what's -3 times -3? We can use a calculator if you want. You can go -3 times -3. Whoops, I have something else in here too. -3 times -3. What do you think it's going to be?
+9.
Yep, +9. So this is x equals 3 plus or minus the square root of 9. Now this is going to be probably too big for my brain. 4 times 4 times 8. 4 times 4 times 8. That's 72. But see the two negative signs? So it's going to be plus 72, all divided by 8. Okay, check that out. Does that make sense so far?
Yeah.
Okay, so 9 plus, oh my gosh, I made a perfect square one again. 9 plus 72 is 81. I meant to make one that wasn't a perfect square. X equals 3 plus or minus the square root of 81 divided by 8. Dang it, this isn't what I want. I made this one up too, and it's still a nice square. You know what the square root of 81 is?
9?
Yeah, it's 9, because 9 times 9 is 81. I meant to make one that I had to grab a calculator on, but this one is 3 plus or minus 9 over 8. So the two answers are 3 plus 9 over 8 or 3 minus 9 over 8. It's 12 over 8. If I divide out 4s, I get 3/2, 1 1/2. And this one is -6 over 8, or -3/4. There's the two answers. And you can use decimals for these too if you want. If you're not quick with fractions. I like fractions, but a lot of students don't. So you can just grab a calculator and go 12 divided by 8 and you'd get 1.5. And -6 divided by 8 and you'd get -0.75. Those would be okay as well.
How do you put them into fractions? Like if they're on the quiz, how would I know which fractions?
So
I'll give you a while. Go.
this, you see where the 12 came from? 3 plus 9 is 12 divided by 8. So that's the fraction right there, 12/8. And then I just reduced that fraction. I divided the top and bottom by 4 to get 3
okay.
halves. And this one I went 3 minus 9 to get the 6. 3 minus 9 is -6 over 8. So that's -3/4. But the decimals are probably just as easy, and I bet they would have those answers too. Sometimes though, let me see if I can make up one that you have to use the calculator on, because sometimes you get some that don't work out real nice. If you have something like this, x squared plus 5x minus 2 equals 0. I can tell A is 1. You see it there, the invisible 1. B is 5. And C is -2. And now using the formula, here's the formula again. X equals the opposite of B plus or minus square root of B squared minus 4AC, all divided by 2A. Let's see, to get my two answers for X, the opposite of B, -5, plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So -5 plus or minus the square root of 25 plus 8, all divided by 2. So let me see, 25 plus 8, that's 33. -5 plus or minus the square root of 33, all divided by 2. This one just doesn't turn out quite as nice. Square root of 33 is not a nice perfect whole number. Square root of 33, because I know 5 times 5 is 25 and 6 times 6 is 36. It's going to be somewhere between 5 and 6, but it doesn't turn out a nice whole number. So you're going to have to grab a calculator and figure out what the square root of 33 is. That's how I put it in my calculator. You'll have to, whatever calculator you use, you have to figure out how you put in the square root. Square root of 33 is, ooh, it's a big old irrational number, 5.74456. I'm going to round off to 2 decimal places. So 5.74. This is -5 plus or minus 5.74 over 2. And now is where I'm going to split it up into 2 equations. -5 plus 5.74 over 2. And the other one is -5 minus 5.74 over 2. And calculator's my friend on these problems, that's for sure. So -5 plus 5.74 equals 0.74. Divide by 2. That's 0.37. There's one answer. And this one, -5 minus 5.74 is -10.74. And divide by 2, that's -5.37. There's the other answer. So often when you are trying to find the roots to equations or the solutions, they're not always nice whole numbers. Sometimes when we practice, we get ones like I started off with, where you end up with a nice perfect square and you can do all the math. But often, especially in real life problems, you get ones that this number isn't a nice perfect square, so you're going to have to use a calculator to get the answer.
Are there other like problems where you have to use the greatest common factor?
If you're going to use the quadratic formula, you don't have to use the greatest common factor. If you're going to factor and get the answers by factoring, sometimes that's the easiest way to do it. In fact, that usually is the easiest way. Let me see, give me a second, I'll write one like that.
Okay.
Okay, so if you have this problem, 3x squared plus 21x plus 36 equals 0. Again, you have to have that equals 0. So if I want to find the answers to this one, I could use the quadratic formula. A is 3, B is 21, C is 36. It'll be pretty big numbers, but the formula works every time. But also, notice a 3 goes into all of those numbers. So if I divide out a 3, it'll be 3 times x squared plus 7x plus 12 equals 0. Okay, look at that closely. Do you see what happened?
Yeah.
Divided that by 3, divided 21 by 3, divided 36 by 3. And now what's inside the parentheses, that factors pretty easily. I bet with just a little bit of thinking, you can think of things that'll multiply to be 12 and add up to be 7. There's not too many choices that multiply to be 12, are there?
No.
See, 1 times 12, that won't add up to be 7. 2 times 6, that won't add up to be 7. 3 times 4, there it is. 3 times 4, that adds up to be 7. X plus 3, x plus 4. And now I can find my solutions to this because I know that either x plus 3 equals 0, or this set of parentheses, x plus 4 equals 0. So x is 3, or x is 0 minus 4 is negative 4. X is negative 4. There's my two answers. Oops, negative 3. I left off a sign there. So x is negative 3 or x is negative 4. So you can find the answers using the formula. Some people just prefer to use that formula every time. Sometimes this is pretty quick. Factoring, after a while, especially with certain numbers, you get so you can factor pretty quickly.
There was another question that I was having trouble on.
What is it?
I'm trying to find it, but it was on the quiz and I was having so much trouble on it. Oh, it was when the 2x squared was on the other side of the equal sign.
Okay, read it to me.
2x squared equals 18x plus 20.
Because you have to have that 0 there. So what if I go like this? Minus 18x and 2x squared. I have to minus 18x on this side. Minus 18x equals 20. And then minus 20, minus 20. A lot of people wouldn't take 2 steps to do it. They'd just do it quickly. 2x squared minus 18x minus 20 equals 0. Now I can solve this. I just want to get the 0 over here. So I subtract this and I subtract this. A lot of students just remember if something jumps to the other side of the equals, it's going to switch signs.
Okay.
Oh, do you see something? You see a greatest common factor?
2.
Yes. 2 times x squared minus 9x minus 10 equals 0. So 2 times, can you think of things that multiply to be negative 10? That means one's going to be positive, one's going to be negative, and add up to be negative 9?
1 and 10.
1 and 10, yep. X, 1, 10. Which one do I want to be negative and which one do I want to be positive? I want to add to be negative 9.
So the biggest number negative and the smallest positive?
Perfect. Yep. Negative 10 and positive 1. Those will add up to be negative 9. And now I can get my answers. Either x plus 1 is 0 or x minus 10 is 0. Minus 1, x is negative 1, or plus 10, x is 10. There's the two answers.
Oh, okay.
Sorry, I was shaking there. I have to keep touching my iPad or it will go back to the screensaver.
That makes a lot of sense.
Very good. Tony, are you still there? You just listening?
Yeah, just listening.
Okay. If you have questions, be sure you ask, okay? Yikes, sounds like something broke.
That's my dog ringing the bell to go outside.
Oh, you have a smart dog.
Yeah. Scratches the paint on my door, though.
The bell does?
Yeah.
We have a doggy door, so ours just go out the doggy door. I don't know if they'd ring a bell for us to let them out. That's kind of cool.
Thanks. I wouldn't trust it because my dogs sometimes bring back squirrels.
Oh. Our dog, one of them caught a bird one time. We had all over the backyard. We had feathers, and my husband had to throw the dead bird over the fence, and we cleaned up all the feathers. It was terrible.
I have just a bunch of possums and skunks and squirrels in my backyard.
Good grief, where do you live?
I know, you would think I live in the forest.
Yeah.
Can we do one more quadratic equation?
With the formula or by factoring?
The formula, a harder one for just in case on the quiz.
Okay, let's see. How about this one? X squared plus 5x plus 1 equals 0. Okay, so can you tell what A, B, and C are?
A is 1, B is 5, C is 1.
Very good. Seems like those are nice, easy numbers, but they're not going to work out very good, I don't think. So let's see. The opposite of B, well, x equals the opposite of B, so it's negative 5, plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. Okay, check out all those numbers. That makes sense where everything's coming from?
Yeah.
Okay, so let's go on. Negative 5 plus or minus the square root of 25, 5 times 5, minus 4, 4 times 1 times 1, all divided by 2. So negative 5 plus or minus the square root of 21 over 2. And that's where I knew this wasn't going to be very nice. 21 doesn't have a nice perfect square answer, does it? I'm going to have to go to my calculator to get the answer there. The square root of 21 should be somewhere between 4 and 5. The square root of 21 is 4.58 approximately. So negative 5 plus or minus 4.58 all divided by 2. So my two answers, negative 5 plus 4.58 over 2, or the other one is negative 5 minus 4.58 over 2. And here it just becomes a lot of calculator work. So negative 5 plus 4.58, that's negative 0.42. Negative 0.21, there's one of the answers. Or let's do this, let's see, negative 5 minus 4.58, that's negative 9.58 over 2. It's negative 4.79. So the two answers, negative 0.21 and negative 4.79.
Okay, I think I have this down now.
The formula, it looks really scary actually when you look at that formula, but it works out pretty well.
Yeah, once you break it down and like do it over a couple times.
Mm-hmm. And if you can tell what A, B, and C are, and you've got that down easily, then you just have to be slowly going through it.
Okay.
Hey, Tony, what are you working on?
Algebra 1.
I'm sorry, I didn't hear that.
Algebra 1.
Algebra 1?
Yeah.
Which section? This is from semester 2, isn't it, Talia?
Mm-hmm.
Yeah.
I think I've done the first semester, I think.
The first lesson in Algebra 1 in semester 1?
Yeah.
Is that the lesson? I think they have lots of sets of numbers.
Yeah, working with real numbers.
Like rational numbers and integer.
Yeah.
Yeah. Do you have some questions on some of those?
Yeah, in the video, there's notes in there. Is there any way I can blow those up so I can see them?
Oh, I think I sent a message to you. Now the name Tony starts to ring a bell to me. I think I sent a message to you today. When you're watching the video, if you look down, and I sent you a picture, so look in your messages on your dashboard.
Okay.
I sent you a screenshot of how you can make the video bigger. Down in the bottom corner, there's it's like a square. If you click on that square, it will make videos bigger and they'll fill up your whole screen. Are you looking at it on a computer, or are you looking at it on a computer, not on your phone?
Yeah, on my laptop.
So I think you can make the video bigger if you hit that button. So look in your messages. There's a screenshot of where the full screen thing is, and that might help you. It would definitely be better if you could see it, wouldn't it?
Yeah. Actually, it's been like 12 years since I've been in school, so like, I don't know, I don't understand none of it.
Well, I know in the first couple of sections, they talk about different sets of numbers, like the natural numbers and counting numbers. Those are numbers like this: 1, 2, 3, 4, 5, and so on.
Yeah, those are natural.
Talking about yeah, if you're talking about integers, that's a word that a lot of people aren't familiar with.
And that's also positive and negatives and sets, right? And zero.
And zero, correct. It's like these numbers, -3 and everything on this way. -2, -1, 0, 1, 2, 3, and everything this way. Those are integers. If you're talking about rational numbers, technically rational numbers are any numbers that could come from a fraction, but most of us just think of almost everything. It's all like, I have to draw a picture of it on a number line. Rational numbers are all the in-betweens too, not just these tick marks on my number line. And see how I have arrows on the ends of the number line? That just is symbolic. It shows it keeps on going. But rational numbers aren't just these ones that are right on the tick marks. It's all the in-betweens, like the half and the 3/4 and the 1.9 or the -2.2. It's all of the in-between numbers as well. Those are rational numbers. And irrational numbers, that's the weird ones. Irrational numbers are numbers that can't be made into a fraction, which it's really just oddball numbers. It's like a few minutes ago, if you were listening, when I was looking at the square root of 21 on my calculator, if I get the square root of 21, it's 4.5827565, and actually it would keep on going farther than that too. If I had a bigger calculator than this, it would keep on going. Irrational numbers are those weird numbers that keep on going. They don't end. They don't repeat a nice pattern. They're just weird ones. Numbers like, or the square root of 21. They're the funny ones. That's why they're called irrational. They don't really make sense in our mind. And we don't work with those too often. I mean, rational numbers are all of the in-betweens, the decimals and the fractions. Integers are the positives and the negatives, but just the whole numbers. Yeah. So I think you also have to do a little bit of fraction work in those first couple of sections.
Yeah.
You have to add and subtract fractions. Do you need to review that?
Yes, please.
Okay. If you have something like this, like 2/3 plus 1/2, it's a nice, easy one. You have to get a common denominator to add fractions. So you look at the 2 and the 3, and you think in your mind, what's the first number that they'll both go into? In this case, it's 6. Often you multiply them together, but sometimes there's a smaller one. Okay. To change thirds into sixths, you have to multiply the top and bottom by 2. So I'm going to go 2 times 2. 2 times 2 is 4. 3 times 2 is 6. That's good. To change 2 into 6, I have to multiply the top and bottom by 3. So I'm going to multiply this by 3 and this by 3. 1 times 3 is 3. 2 times 3 is 6. Now that the denominator is a common denominator, I can add those up. There's my answer, 7/6. Or some people, like a long time ago, math teachers used to say, oh, you can't leave it improper like that. You have to change that to 1 1/6. Either one of those is okay answers.
Okay.
Same when you subtract with fractions, you have to get a common denominator. If you have like 3/4 minus 6/7, you're gonna have to find a common denominator. 4 and 7, I think the first thing they go into is 28. 8, I mean, 28. That's a funny looking 8 now, but so to change fourths into eighths, you multiply by 7. So this will be 21/28. Do you see where the 21 comes from?
Yeah.
Yeah. And to change 7 into 28ths, you multiply by 4. So 24/28. And now when I subtract 21/28 minus 24/28, that's -3/28. 21 minus 24 goes below 0. Okay, and then you have to do some multiplying and dividing with fractions. That's actually easier than adding and subtracting. You don't have to get common denominators. When you multiply and divide, if you have like 2/3 times 6/5, you just multiply across the top and multiply across the bottom, and then reduce your answer. 12/15. You have to think of something that goes into both of them. 3. So if I divide 3 out of 12, I get 4. If I divide 3 out of 15, I get 5. There's the answer. 12/15, which reduces to 4/5.
Okay.
When you have a divide problem, this is what sometimes students forget. I'm just trying to make one up. Let's see, if you have 3/4 divided by 1/2, it's the same as a oh wait, my screen froze, didn't it?
Yeah.
My dogs, just a second. There we go. Is it back on now?
Yes.
Okay, sorry about that. So if you have this dividing problem, it's the same as a multiply problem, only it's one step longer. When you divide, you multiply by the reciprocal. So you keep this first fraction the same, you change the divide to times, and you want the reciprocal. That means turn this one upside down. The second fraction gets flipped upside down.
Okay.
And now it's just a multiply problem. 6/4, that reduces to 3/2.
Okay.
I had another question.
Yeah, tell you what.
I was also having trouble with solving quadratics by completing the square.
Oh, okay. So when you complete the square, let's look at one of those first. If you have something like this, x² plus 8x plus something. To make a perfect square trinomial, you have to take this b term, the middle term, cut it in half, that's 4, and then square it. 4 times 4 is 16. That makes a perfect squared trinomial. Look, x, and things that multiply to be 16 and add up to be 8 are +4 and +4. Or x plus 4 squared. That's called a perfect square trinomial. And let's look at one more before we do a solve by completing the square. So if I have x squared plus 10x plus blank, and I want to make a perfect square trinomial, got to look at that 10, cut it in half, 5, and then square it, 25. That makes a perfect square trinomial because x plus 5 times x plus 5, those two multiply to be 25 and add up to be 10. Or that's x plus 5 squared. So if you've got, now I have to think if I can make up a problem like this. Say you have okay, so if you have this problem, x squared plus 6x equals 12, and the directions say to solve by completing the square, here's what you'd do. I like to write it even with a blank like I had before. X squared plus 6x plus blank equals 12 plus the same blank. And just ignore that for a second. What would complete the square over here? You have to look at that 6, take half of it, and then square it. So look at the 6, half of it is 3, and then square it, it's 9.
Yeah.
Yeah, so you add 9 to both sides of the equation because you have to keep it balanced. This makes a nice perfect square. It makes x plus 3 squared, x plus 3 times x plus 3. This side makes 21. And now I can get my answer. The square root of x plus 3 squared equals the square root of 21. Your doggy wants in.
Yeah, she
I think
does.
we have to put a plus or minus with 1. So x plus 3 equals, and oh, I already had the square root of 21 a while back. Square root of 21 is 4 point something. Square root of 21 is 4.58 about. And I can get my two answers. I have to subtract 3. Subtract 3, subtract 3, but this is really two different problems. It's positive 4.58 minus 3, and it's negative 4.58 minus 3. And those will get me my two answers. (4.58) minus 3 is 1.58, and negative 4.58 minus 3 is negative 7.58. There's the two answers. And honestly, when you complete the square, most people don't solve equations that way. Most people use the quadratic formula or factor. Later on, when you take some other math classes, you'll need to know how to complete the square, and that's why they have you learn it here. And you can kind of see this is how somebody did these problems over and over again, and that's how they figured out that quadratic formula, by completing the square. And by doing these problems over and over again, they figured out there's a pattern with the numbers in front.
What about those questions where there's only like a one choice answer?
Wait, like you have to put in your answer? Oh, if you have just one answer, not two, you mean?
Mm-hmm.
That would be if you have something like this. If you have, let's say I have this, 4x, well, wait, I'll make one I can do that I know it's going to work out. X squared plus 14x plus 49 equals 0. Look what happens here. So A is 1, B is 14, C is 49. X equals the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So negative 14 plus or minus the square root of 14 squared, that gets pretty big. 14 squared is 196 minus 4 times 1 times 49. 4 times 1 times 49, that's 196. Oh, look at there. All divided by 2 times 1. So it's negative 14 plus or minus the square root of 0, all divided by 2 times 1. What's the square root of 0? What times what is 0?
I don't know if is that possible?
How about 0 times 0?
Oh, yeah.
Okay, so negative 14 plus or minus 0 divided by 2. My two answers are going to be negative 14 plus 0 divided by 2 and negative 14 minus 0 divided by 2. Negative 7 or negative 7. I guess it's negative 7. There's only one answer. If what's under the square root turns out 0, there's only one possible answer. If what's under the square, oh, I'm sorry, what?
Can you solve this equation? X squared plus 6x equals negative 8.
So do you want to solve it with the formula or by factoring? Because either way will work. We have to get a 0 over here first. So I'm going to add 8 to both sides. X squared plus 6x plus 8 equals 0. Now you can either figure out A, B, and C and use the formula, or you can factor. I always try to factor first if they're little numbers. I bet you can factor this one. Some things don't factor. They're not nice, easy numbers to work with. But 8, can you think of things that multiply to 8 and add up to be 6?
2 and 4.
2 and 4. X plus 2, X plus 4. That means the two answers are negative 2 and negative 4.
But for this one, it's solving quadratics by completing the square, and there's only A, B, C, or D.
So they want you to solve it by completing the square?
Mm-hmm.
You should still get those same two answers, but if I do it by completing the square, x squared plus 6x plus, I'm going to put a blank there, equals negative 8 plus a blank. So half of 6 is 3. 3 squared is 9. I'm going to add 9 on that side. This factors into x plus 3 squared equals 1. By square root both sides, x plus 3 equals plus or minus the square root of 1. The square root of 1 is 1. So x plus 3 equals positive or negative 1. And now I have to split it into two equations. Am I staying on here? X plus 3 equals 1, or x plus 3 equals negative 1. Take away 3. There's one answer. Take away 3 here. There's the other answer. So x is negative 2. And they only have one answer there?
Yeah, the answers are A, 6, B, 3, C, 9, or D, 8.
Why, yeah, man, I don't know. I'll have to look back at that one. And that, which section is this on? Because there's two answers there. It's negative 2 and negative 4. Or does it say what do you have to do to complete the square?
What number needs to be added to each side to complete the square?
Ah, look, what do we add to each side?
Oh, 9. Okay, I was really confused.
Yeah, it's the directions that are confusing there. It doesn't say to go ahead and find the answers. It just says, what would you do to both sides to complete the square?
Oh, okay. Then, yeah, I got this. I got it.
Very good. These are hard problems.
Yeah. But notes are keeping me steady.
Good, good. Somebody just joined us. Hi, Remy. Remy? We're just about finished, but if you have some questions, we can go over them quickly. Are you there, Remy?
They just left. I think they were trying to chat in the group chat.
That could be. Okay, well, we've been here about an hour. Do you guys have any other last minute questions?
No, I'm all good.
I'm glad, Talia. How about you, Tony? You okay?
I'm good.
Okay, good. Well, feel free to text me if you have any other questions. I left on the message that I sent you, Tony, I left my text number.
Okay.
Okay. It was nice working with you guys.
Thank you.
Keep up the good work.
Thank you.
You're welcome.